Hello, welcome to my laboratory. The last set of videos where I demonstrated Orbette as a pulse motor may have confused some people into thinking that Orbette is a pulse motor and does not operate in the core repulsion or core neutralization mode. So what I've done is I've set it up with the toroidal coils, positioned them exactly so that the points of them are right opposite each other. I've removed any biasing magnets, and let me show you where it's timed. We'll turn the switch circuitry on, and then we'll rotate it by hand. Ding. So it's turning on right at top dead center in the direction of rotation. Bing. Bing. Okay, like that. And that's the other direction of rotation there. And as you can see in the other direction, it turns on well in advance because of the way the Hall sensors are timed, okay? So, one way. And so here I'm going to go ahead and plug in the external power and give it a little starting spin. Okay. Now we're running on the C cell there, and that's the input voltage. That's the input current. Okay, and there we're accelerating. And there's the, oops, sorry, you're supposed to be in bed by now. There's the speed increasing. And let's see what happens when I reverse the coils. Okay, coil polarity reversal. Slows down a bit, but still runs. Okay, still running. And let's see what happens if I do the hand start thing. If I try to start it running in that direction, it does not run. And if I start it in that direction, it runs. Right? And if I reverse the coil polarity and I try to start it in that direction, it does not run. And it does run going the other way. Now it's a little bit more eager to run going the other way when I have it in this polarity. That's probably because of asymmetries in my construction. Okay, but the gist is that it is running as a core effect motor, not a repulsion or attraction pulse motor. Okay, now let's see if we can take a look at the scope traces here. It's running slowly in that mode, but let's see here. Well, that didn't help very much. Sorry about the light. Okay, so current on the top, voltage on the bottom. Now bear in mind that my scope gradical is actually tilted just a little bit from the vertical, right? Like it's not completely horizontal, like from the horizontal. If you look very closely, you can see the gradical lines. They're not completely horizontal. So this top trace here, which is just a little bit not horizontal, is actually horizontal with respect to the scope's gradical lines and calibration, okay? Boom, straight, straight. And that's that inductive feature that shows up quite well in Sean's traces. There's the inductive rise, there's the spike on the trailing edge, and as you can see, we have that flat tops. Now I'm going to do the FFT. I'll just drag it down to a stop and start it again. Let's see if I can keep the traces on there. So you can see that those traces, I hope you can tell that those traces stay flat across the top, except for that little inductive feature right at the beginning, no matter what the speed is. And let me get the actual trace back in there. There you go. Okay, so Orbette operating as a pure core repulsion motor, minimal effect of changing coil polarity, still wants to start and run in the same direction no matter the coil polarity, flat traces on top, constant voltage, constant current characteristic with respect to shaft load, no biasing magnets, running on a D cell, or C cell rather, at very low current consumption, bearing in mind that I have a lot of overhead for my MOSFET switching circuitry. Okay? What else is there? Oh yeah, free energy. I can't accommodate you there, not yet. Thanks very much.